Chapter 7. What did we do last? Right, we were working with this logic monad thing. Yeah, so I think we were on section that's called comprehensions and guards. And then we were moving on. What was the last? Yeah, look at that. I try to put in where we are in the logs so that I can just do this, but sometimes I forget that I do that. So, you know, I didn't look there, obviously. So we're gonna put this stuff up here. Oh, sorry, I'm cleaning up. So, and in there. Okay, cool. There we go. So yesterday was a really fun day. I don't know if you were able to catch the stream, but we had a ton of fun yesterday. And I think that we're gonna make it even more fun for viewers, trying to figure out how to make that happen and thinking very carefully about that. So stay tuned for some more information about our category theory for programmers book club. I had a lot of fun doing that. Okay. So here on Tuesdays, just for reference, if you're new to the stream, we're working through this book. This is kind of this is normally what we do on the stream. But I'm working through this book right now, and we are on a section, chapter 7, failure and logic. Jonathan Lorimer hitting us with the Prime sub. Thank you so much, Jonathan. I really appreciate that. I'm excited to hear that you're interested in coming to the book club. So I'm excited that you're going to join us. You sounds like you have a lot of experience with Haskell. Well, I browsed your GitHub page, so I stalked you a little bit, if you will, on GitHub. So it's exciting. And I think we've had some interesting conversations today, and I'm pretty excited for where that's going to go. So it's good stuff. All good stuff. We had a lot of fun yesterday. I got to figure out how to manage all of the stuff. That was really hard for me. I've never had to do that before. And guards. Never had to do that before. Thank you so much for that sub. Very nice of you. I'm buzzing. That over there, so I don't buzz. All right. So this is basically just showing us how. Oh, you know what? We had this question before: how comprehensions are actually expanded, and it shows us how right here. So if we had something like the following, I can't use X. I'll just use XS because it's a list. X, Y, X, NS. So I guess this needs to take NS, Y, NS. Oh, that's not supposed to be. That's supposed to be a comma. Sorry. And also, let me do this. There we go. Okay, so Y, NS, and prime X, Y, probably. Oh, X plus Y. And we can put a $sign here. I prefer the $signs, just a habit. Does this exist in Haskell? Google Prime. Data number primes. Does this just generate like Is there no function that generates a prime? Huh. Maybe it's called like is prime? I don't know. Okay, whatever. We'll just to make this type check, we'll just do this. Yeah, it doesn't look like it either. Also, hey Lumi, what's going on? So we'll just do this for now, just to make the type checker happy. It says the Haskell report literally translates this to the following. YSNS concat map I'm gonna put this on the next line. Concat map prime x plus y, then are you working through Learn You a Haskell or the Haskell book? We actually finished both of those books. The title is not correct. Shoot, I forgot to change it. Thank you. I totally forgot. Book of Monads, chapter 7. Thank you. Oh, you know what? I can do that from the title command as well. Okay, so yeah, I did Learn You a Haskell as my first book that I tried to learn Haskell from, and I just didn't have good luck retaining the information, I guess. And then we've done Haskell book on stream, but I wasn't allowed to put any of those videos on like YouTube, so they're kind of just gone forever, unfortunately. But I think that my ability to comprehend the Haskell book was pretty darn close. There were a few chapters that I had a hard time with, which is part of the reason why we're working through the Book of Monads. So, like, I had a lot of trouble talking about like monad transformers. I'm still having a hard time working with, although I'm feeling a little more comfortable about things like reader, writer, state, and those sorts of things. So I'm hoping that this book helps, basically solidify my understanding of monad transformers, and we'll see if it does. If not, I'll just keep practicing. So Learn You didn't work for me either, but the Haskell book worked pretty well for me. Yeah, I would agree with that. I think, again, there's just a few things that I had a lot of trouble with, and I still think that that's probably just because I'm a naive software programmer, just like in general. That's funny. So the above is literally translated to. I would actually like to go back through like Learn You a Haskell and even the Haskell book after we finish these, just to see if I get glean any more information that I may have missed. We've also done the Thinking with Types book, which was a mind-blowing book, but I think it did really help me understand Haskell quite a bit as well. Doing that type level stuff really opened up my brain for absorbing Haskell. That was a very fun book, and that code's all online as well, and I took videos of everything, so that was a pretty fun book. Okay, so apparently this is the literal translation of a list comprehension. I feel like I haven't programmed in a while, which is bad because I'm going to be really slow today. Yeah, that book was awesome. So it says comprehensions can be generalized to work for any monad, In particular, we can replace the list operations with their generic versions, i.e. concat map with bind, and list of x with pure, and empty list with m0. So let's write that. Or for a generic monad, I'm just going to replace these and then fix them in a second. So this will be pure M0. Oops, if I could spell. Although these are backwards, right? It's supposed to be NS like so, and the same thing here. And then we can get rid of a few things here. Pattern match is redundant. Pattern match. I don't know what that means. Well, it didn't do anything. Sometimes the linter will say things like this, but it won't actually apply. I'm not sure what that's all about, but you know, it's fine. YS. Oh, thank you. I see what it's saying. It thinks that these two things are pattern matches, which they're not. Good call. Thank you, Lumi. I wanted to write ZS and I wrote XS twice, actually. Okay, so that should be that, I think. Let's see if I get it right. I'm pretty sure I did it right. I mean, it type checks, and in this case, this is a simple enough function that it should work. So, Jappy, I'm working through the Book of Monads. So this is what we do on Tuesdays. I don't know if you've ever been around here on Tuesdays, but this book sitting in front of me, just like, you know, category theory book. And right now we're talking about how list comprehensions are expanded for the list monad and then a generic monad. What's a monad? I don't think that's a serious question, but I will answer it anyway. So a monad is a object that has two functions, one of which is return, which is basically like taking something and putting it in a box, for lack of a better analogy, and then a bind operation, which allows you to embed structure and then flatten it. So in other languages, they just call it flat map, and it's called bind in Haskell, and it represents this here. Then the only things that need to be true for a monad to be a monad is they must obey a right and left identity rule and something else, probably some sort of composition rule, but I don't remember exactly what it is. We can go look real quick though. Yep, associativity. So there you go. Yeah, just make fish, I guess, and be happy. Wonderful. Yeah, so that's my understanding of a monad. And like, I remember that I think that people have like this weird reverence for the term monad, and like that it's magic or something. And I remember in the Haskell Programming from First Principles book, it was like it's just like a thing with these two methods and some laws, just like functor, just like semigroup, just like all of these things. And it's not magic at all. It just allows you to sequence effects, essentially, is the whole point. So I like not thinking of it as magic as much as possible. I think that's a common misconception. And no, I'm not writing a monad blog post. Don't worry. Oh, and then there's one point is that this can be, yeah, like it's just sequencing effects. Can you do monads at the type level? Yes, you can, except that the syntax looks a bit different. So in the type level, you use a function that's basically flip Kleisele. So it's this operator, and that works like, wait, no, I'm thinking about this wrong. Is it right? No, this behaves like, no, this is supposed to behave like function application. So no, I don't think you can. Although now I'm doubting myself. I'm doubting myself pretty heavily. Yeah, I'm not 100% sure now. So yeah, we should look into that though. Well, actually, let's just look into it now because we can. So monads, type level, Haskell. That's clearly not going to help. How do I Google this? At the type level. Yeah, I don't know how I... Yeah, it's very clearly, it's all just monad transformers and things. We'll have to go look at the book again. Let me write this down, Jappy, and let me see if I can find it in that Thinking with Types book again. But I don't remember it being there, so... Oh, I don't need this. Oh, we can just put it under here. Because even if I can't answer this, I probably know people that can, so I should ask them. For example, I think the author of the book would be willing to answer that question via email, but I can ask other people's first. Yeah, I think Lumi's right. It would be a lot of work, but I think it could be done. So anyway, they're just pointing out that we can modify this a little bit. Notice guard. So it's essentially like I think it's like this. Yeah, so the only difference is they're using return, but I always tend to just use pure, and in most cases they're the exact same implementation anyway. So you are you are required to use the monad because you're asking for bind here, but I tend to write pure instead of return. It's just out of habit at this point. And then it says it's some comparison to Scala. I think I'm just going to skip it. It doesn't really interest me to talk about these differences yet. Have I come across arrows yet? I know they exist, and people have told me that things would be easier with arrows. And actually, I think even the linter has like put arrows in my code before. So I know they exist, but I've not spent a lot of time with them yet. But that's something that I want to do at some point. Okay, so next one, catching errors. This is 7.3. Oh, something else that I got a little bit ago, by the way. I just got confirmation that I can do the purely functional data structures book. So I'm plan on doing that at some point. So right now we have, that's probably the next book on the list. And then I also have the parallel and concurrent programming book. So those are sort of the two on deck books that I'd like to work with, but we're streaming a little bit less now. So I don't know when we're going to get through them, but we'll see. All right, so catching errors. So alternative and Monad Plus embody a style of programming in which errors may occur, but we were never interested in inspecting or reasoning about them, only trying something else via the alternate operator. But in many scenarios, we definitely need extra functionality for inspecting errors, which we refer to generally as catching or handling. Several of the monads discussed in this chapter provide an interface for that purpose, in addition to their Monad Plus. For example, Haskell's MTL library calls it monad error. What does this mean? Okay, let's just write this class out. So Simon, only arrow functions I use are first, second, and star, star, star. Okay. The purely functional data structures book is in standard ML. They have standard ML and Haskell translations in the back, but I'm going to try and not look at the Haskell translations as much as possible and just convert from the standard ML. So we'll see how that goes. It doesn't look that terribly different, the code that I've seen thus far. Oh, Simon. So Simon yesterday, I think it was yesterday or this morning, submitted a PR to the Category Theory for Programmers GitHub page. And so we're having conversations in the meetup group of considering making the book club more open. So we don't know exactly how we're going to make that work yet, or if I'm going to do it. But that's the idea. So if we could make it open and have all of you, oh, I'm sorry, I just bumped the mic. Hopefully that wasn't too loud. If we could have like all of you in the chat right now on in the book club speaking with everyone, I think that would be really cool. But it's going to be tricky to get right. So one of the ideas that we had was, well, what if I kind of just moderate all of the conversation and not pay so much attention to the book, like the content itself, and then just like rewatch the video the day after, something like that, so that I can get the content myself. And that way we could probably, moderate all of you in chat, hanging out and, talking about category theory. So that's kind of the plan. We'll see if that actually goes through. That's not like, yes, we're doing that. It's just an idea. Yeah, so that was the original intent, but we had some nice conversations in the meetup today about like, or in the Slack for our meetup, like, wouldn't it be interesting if we could make it so that all of us were having discussions together? And, as long as folks aren't being malicious on purpose, then I think it would be a very useful and interesting thing, especially because I know there's people who watch this stream who are very good at this. Yeah. So like one idea that I had was like I'm gonna write out more of a like a list of things that we should cover in the book, like more planned. I usually just kind of wing this. I don't have any plan for what I'm doing. I just open up the book and start going. But in that case, I was going to have like topics that we should discuss and have people vet them before we even do it, and then set aside dedicated time for each of those little topics. And then also there's like a function in Zoom where you can be like, I raise my hand, I would like to speak now. And then I will like say, yes, it's your turn to speak, and you can speak for 2 minutes, something like this. And then just try and mitigate time, or not mitigate, like handle time and be careful and methodical about how we approach this. So that's kind of the idea. We'll talk about that more next time. Yeah, we might be able to do that too, but people seem to think in the Slack that we might be able to even open up the conversation for people that want to. Obviously, you don't have to. You don't have to join the audio, right? You can just hang out. That's in the chat. That's totally fine. And as long as I can spend some more time, like I was trying to do what I'm doing here, is like I'm trying to understand this book while managing all this stuff going on, and I just don't feel like I can do that with all of this stuff going on. So I need to pay more attention to the chat and the voice conversations of who's talking when and da 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 da, what we're talking about, and then move forward. Yeah, I agree with that, Lumi. I don't want to make it like this is all we're going to talk about for 15 minutes. It's like, no, let the thing go. But if we have an idea of blocks of time, I think we can make it a little better. We'll see. I mean, I literally don't know how to do this, and I don't know anyone else that's doing this offhand with arbitrary people. So I don't. As far as I know, there isn't a this is the way you do this. So maybe we need to invent that. That was what came out of our conversation today, Chappie. It's like if I'm not steering the conversation, it's just not going to go anywhere. Or we're going to talk in circles, or people might talk over each other. So anyway, we're thinking about it. I promise. I had a lot of fun doing that. And I totally don't mind if I have to, not pay attention for the first day, or, the actual stream, and spend my time thinking later about the chapter. Before and after. I really don't mind that at all. If people are getting something useful out of it and people are enjoying it, then that's what I think really matters. Okay, I gotta get back into this though, because I'm thrown off. Okay, Lumi says, yeah, I actually only know those from doing in-person workshops or related structures. Yeah, and actually some of the Discord groups that I'm a part of, they do like book clubs, but on more specific topics. I think they do like math book clubs. Oh, thank you. Yeah, you can see I'm kind of distracted. I'm thinking about too many things. But this is going to... Oh, right. This isn't defined, so I do need what? What am I doing? Isn't it? Yeah, okay. Functional dependencies. We'll see if we can get this to... Yeah, wonderful. All right. The group size here should be comparable. Yeah, because it was popular, we did have at the peak amount of folks watching was 26, I think. So, you know, I don't think all of those people, like a lot of those people are rotating in and out. So the sort of the core group of people, I think, was somewhere around 18. So I think that that could be manageable as long as people follow the rules in the voice chat, right? If they don't follow the rules, then it will be a problem. And I can just kick people. Like, if you're not following the rules, I'm sorry. I'll warn people and just say, go from there. It's the best one yet. That's the most viewers I've ever had. Yeah, so it was popular, which is important. We didn't get like subs or anything, but you know, we got a ton of follows. 6, I think. Let me see here. 1, 2, 3, 4, 5, 6. Yeah, and I mean, I know some of them personally, so I'm not surprised that they followed. But what was my goal? I don't remember my goal. Oh yeah, because Jonathan subbed today with Twitch Prime. By the way, you have Twitch Prime. Yeah, I'll increase it. I'll increase it later, because technically, if I increase it now, I have to like refresh this the overlay, so it doesn't work automatically. Anyway, I'm so distracted. You guys are doing your job. The first thing to notice is monad error takes one type parameter in addition to the monad itself. Yep. Do we get E? Yeah, chat wins. That needs to be a counter. That would be a good counter. I need to shut the door. Hang on. Put Hodor up there. My girlfriend's having a conversation. It's just even harder to think. All right. So, this parameter defines the error we are able to throw and catch. For example, if we have either problem solution, the type is problem. But in some cases, the type is fixed. For example, we can see maybe as a monad error for which the error type is completely uninformative, either void or unit. I'm sorry, unit or unit, not void. Never mind. Let me just be clear. Unit. Put a dash here or something. I've not used MTL yet. Well, actually, that's not true. I've used it, but I don't understand it. So there's a difference there. The two methods of the class provide the two parts of error-oriented programming: generating an error via throw error and doing something in response to one via catch error. Suppose we enhance our random validate name function with reasons for failures. Okay. Yeah, I still don't understand monad transformers, which I'm hoping to get from this book. We'll see. Gotta have a drink of water though. So we're working with, yeah, essentially. Name too long. So we have a sum type, these random subtype, sum type characters. Monad error, name, reason, m, string, m, bool. So, by the way, this is just pointing out like examples of using this, but keep in mind that this validate name function doesn't even exist in this file. So it's just kind of giving you an idea of how to use it and really nothing else, which is fine. I think we can use I forget what these things are called, but there's a type of structure that gets rid of this redundancy where you just write like /e name too long or something. It probably will come up when we do. I think so. Yeah, lambda case. Yeah, so you right, you write case E and then I think the arrow is how it works. Is that right? Something like that. Anyway, the point is that it can be done. Normalize name. Okay, sure. Yeah, right. These functions don't exist. Oh, it's just case. Okay, cool. So we would do case like so. And then, wait, really? How is there no code action for that? Okay, oops. I like that better. I am using HIE, Haskell IDE engine, which I think is different than that. Yes? Jabby, you love those prisms. Yeah, so we're using NeoVim. I have editor. Yep, so there's my NeoVim setup and a video of how you use it, although the setup has changed like a tiny bit. But actually, that's my most popular YouTube video, which is kind of funny. Yeah, okay, so this is cool. The behavior above is something you can't get by only using the alternative operator. Since that operator provides no information about any previous computation, note that in the implementation above, when we find an error, we call validate name again, or VN again, I'm sorry. VN again, so it's recursive. Instead of validate name on its own, to ensure that if the name is both too long and has unknown characters, both errors are handled correctly. Implement the monad error class for the types either and maybe. Okay, cool. So finally an exercise. So this is my favorite part about doing this, is the exercise. That's actually a good question. That's the question I should have asked. Oh, they are the same thing or different things? I just see, yeah, they are. I don't remember what that's in response to. HIE is different. Got it. Yeah, I've never used GHC IDE. Got it. Cool. So exercise 7.5. Implement. Whoops. All right. Here we go. Okay. I feel like I've heard of this before, but I haven't had time to experiment with it, so we should probably do that at some point. Ugh. So now I've noticed that my tab behavior at work and my tab behavior here is a little bit different. I need to unify them clearly because it's driving me a little insane. Um, um, is this... So this means M implies E, right? Something like that. Yeah, unify all configuration is important. Problem is I don't really need GHC at work all the time. Like on all the nodes that I work on, it's kind of annoying because most of them don't have Haskell, and then they annoy me. And also it's really slow for various reasons. What am I doing wrong here? So what... So this is just unit, right? That's the point. Because I can't... If the only error types that are available are these? I don't understand. Maybe this is more clear. So maybe I should think about it as either first. It does have that coming up first. So this is really an either A, and the point is that this has to be A as well, right? That's the idea. So, okay, I think that makes sense. Maybe. Maybe I'm thinking about this wrong, but... it can't be monad error, maybe, because you have another type in here. If I get rid of that, that should complain, yes? Yeah. Can it be A? I mean, I guess it... Um... Oh, it can be A because of fun depth. But the question is, should it be A? I don't really know. So if this was some type B, how do I make a function from a B to an MA? I don't really know what these are supposed to do. So this comes from throw error. And what am I supposed to do with this here? So when we catch an error, we're taking a name. Need to produce another monad of A. How do I implement this for another thing? That's what I'm having trouble thinking about. Right, the only thing I can think of here, just so I'm thinking out loud, I guess, instead of just no, please don't. Let me hate my life for a little bit. I mean, there's something to be said about this as well. Which is why I think it has to be unit and not A. Because how would... I don't know. That can't possibly work because we don't know the type class here. I mean, is that the idea? Yeah. Let me write this one. Maybe it will help. Because is this one just... this? Here, let me move this up, sorry. I'm gonna move this down. It's fine there. All right, so for this one, okay, so what did this one do when we caught? It's essentially disregarding this. And yeah, I mean, it can just be called F. That's fine with me. Sometimes I get a little creative with my naming. But like, I should have called it EMA or something if that's what I wanted to portray or something. Anyway, let's not worry about it. It looks a lot like throw error because it is. So I have an error to this. But I'm basically just pattern matching on this name. I've used E to MA. Yeah, I mean, that's fine. I don't think it's not that important. I like using the short names sometimes because you see the short names in other people's code often. And I mean, we have things like, you know, oh well, we can't use diagnostics right now because it's broken. I like how your names are just a slight different shade of purple. Blah, blah, blah. It's pretty funny. Yeah, it's like 50 shades of purple. We need more shades of purple. Is red considered a shade of purple? I don't think so, but why not? I think my name is purple as well. So we just need a function that generates this. Nice. I like it. So f is just a function that generates an MA. What do I do with this? I don't understand. Is this like really easy and I'm just being silly? Well, okay. Yeah, that's what I'm thinking about here. So, I mean, f can only be a unit. To some monad. But what does that do for me? Let's write it down. I don't remember who told me this, but somebody told me this. It was probably Lumi. Write stuff down when you don't know what you're doing. So like this is f essentially. It has to be. And this can't possibly be right. It might be right, and this is just because it's a weird example, but like I can't do anything else. Like I just need to get that monad out. So if I apply unit to f, then I should get, you know, whatever this is. Yes? Always executing the catch block. So then something like this. I'm having a hard time thinking about this. Sorry. Conceptually, what is the first arg supposed to be? Nothing. Oh, well, it could be a just. Right. So if it's a just, you basically want to ignore this. I see. Otherwise, you're doing... Thank you. The try block. Yeah. Okay. No, I get it now. I get it now, right? Because I was thinking, I think my brain is still a little melty from yesterday. So we talked about that a lot at the beginning. So yeah, this makes sense, right? Because if it's the try works, then I'm gonna get something, and really what we can just do is, you know, we can just do this, because this doesn't matter. I don't know if there's an easier way to say this. I mean, this seems like the only way to do it. Excuse me. But in this case, f can only be one thing, so we can just apply it to get that thing back out. Oh, sure. Okay, just pull out, right, pull out the cases here. I like that. I don't need to pull them out here. What did I just do? Something like this. I like this the better. Okay. So let's try the same thing down here. Although I feel like it's going to be... kind of similar. Because that would be for a right. But for a left, let's do the same thing because that will help. So this is now going to take that E, so it's just FE. That was a lot easier. Well, it's only easier because I did the first one, but I think that's right. All right, so let me think about this like fundamentally. So try if this thing is the what would I call this? Like the positive outcome, like just and right are the affirmative outcomes or something. I'm not sure what the right term is. Then you just send the thing because it's right, and we just, you know, we've not had any errors. Our try blocks succeeded. Happy path. Yes, our happy paths. If they succeed, we ignore F. Which makes sense, right? Because if you were looking at this example, that would imply that validate name was working perfectly and we don't need to catch any errors. Okay, right, because it's just a try except block. And then if we have an exception, we need to handle our exception by passing it to a function that handles said exception. All right, I'm into it. I know this is like, I write try except blocks all the time, but for whatever reason, my brain's not on the right path. So that's okay. We'll get there. Just gotta get it moving again. So it says, before we move on to the next chapter, let's return to the idea of bifunctors for a moment. The type either is yet another example of a bifunctor, since we can map over both type arguments. But there's more to it. I'm not going to show the bifunctor instances. I think folks could figure those out. Hopefully. If you can't, I can write them. But there's more to it. Let's put side by side the type signatures of the monadic operations and those of monad error, with the type of catch error slightly generalized to allow for the changing of the error type in the handler. Okay, I'll write this just for folks. It might help, I don't know. It might help me too. Oops. Okay, and to the right of it, throw error. You know, the other book I really need to do is the effective Vim book, because my Vim has gotten so bad in the last 2 years. Like, while hating, this has got to be, no, it's FA. My Vim is terrible right now. Are they the same thing? Where did this F come from? EA. All right, so is this the same structure? It doesn't feel, I mean, it's the same structure, but are the types the same? Well, I guess they can't be the same, can they? Anyway, it says either is not only a bifunctor, but a bimonad, a type that provides both binding and returning for each of its two type parameters. That's kind of cool. Oh, I see. Okay, because this is binding on the error, or it looks like bind for the error side of things. Okay, I get it. I get it. I get it, I think. All right, cool. So that's actually chapter 7. We're done. So that's it for chapter 7. Yeah. To be fair, I did a lot of it previously, so merge that in the repo, and we're done there. Wait, the other way. I always do that. Nope. I was right the first time, wasn't I? Oh. Interesting. Okay. Think I'm asleep today. Okay, so chapter 8. Let's get it set up. We don't need this. Don't need that. Put stir. Nope. Sterlin. What do I usually do? Monads for mutability. And in the README, we do the same thing. Monads for mutability. And I think that's it. All right, so this chapter, if you didn't figure that out already, is called Monads for Mutability. And I actually don't remember reading this chapter, but I probably did. What usually brings people into the realm of monads is the need for side-effectful computations, as opposed to pure evaluation. In Haskell, every time you need to read a file or communicate through a network, you are forced to work in the I/O monad, even though you do not really need to understand the concept deeply to start being productive. At first sight, monads are very much about sequence and having a strong imperative flavor. By this point, dear reader, you have seen many other containers and contexts that are also monads. In this chapter, we go back to square one and look at those monads that provide one of the main features of imperative programming, mutable variables. Yeah, I think we're going to talk about state and state references, stref. So the state monad allows us to hide a piece of data which can be transformed during the computation, but that we never have to thread explicitly. This monad simulates a mutable variable conceptually without actually mutating anything. Oh, that's the point. Okay, so not states, because we're not actually mutating, we're just returning new states every time. So I think stref allows you to mutate the things inside of it. One of its shortcomings, though, is that you can only keep one piece of state. If your algorithm requires keeping and updating several variables, using the state monad forces you to put everything into a single value, a tuple or ad hoc data type, and manually querying or modifying the corresponding field. What? I guess this is just an example. I can just show the example. Alg state. Let's do this the way I like to do it. Counter. Visited. You know, I was recently watching something about doing these types of problems in coding interviews. Has anyone done these types of problems in coding interviews in Haskell, where you need things like this? Where you need counters in the nodes you visited? Ew. It was horrible. So this is like pseudo Haskell, unfortunately. Yeah, I've never had to do that, unfortunately. I actually kind of want to, just to experience it. But I'm one of those kind of weirdos. Alright, so we get and modify our counter. Does this require some extra functionality? To do this? It's kind of ironic. I don't mind doing it on stream or for a crowd of people, but on that whiteboard I couldn't think. Yeah, fair enough. I mean, you don't have, so do ... just means like you're gonna do some algorithmic stuff and then, you know, continue. So there's like, it's like first you go get, it's not real, it's pseudo Haskell. So it's like you get your counter and you update it or something, you do some more work, and then you know, push your element on the node, something like that. On the list of node, excuse me. So this is sort of leaving some pieces out because, you know, we don't know what it's computing to before it gets its counter and updates it, and then, you know, what it does afterwards either. So this is what he writes in here. So something like this. I tend not to really enjoy these examples because like I don't fully, you know, I'm not realizing exactly what he's doing all the time. But, you know, unfortunately, these are in the book, so that's what you have to deal with. I think I see what's going on here. It's like, you know, that's what you would need to do to update the state for, you know, every pass of n. Or every item in this list, but you're returning a new state every time. And I think the whole point of these strefs is that you're not returning a new state every time. You're modifying, you're modifying the values inside of the state without returning a new state. So it says the ST monad found in the control monad ST module has an interface much closer to that of conventional imperative languages. You can work with references, another name for immutable variables, by using the functions in data stref. For example, to create a new reference, you use new stref. So maybe we should just go to one of these and just start looking at types. So import excuse me. So we get some A. What is this state here? I guess we're going to find out. As you can see, we cannot create an uninitialized variable. We always require an initial value. The result is an stref holding that single value. Both the stmonad and the stref reference are marked with an additional type parameter that indicates the thread in which the computation takes place. So that's S. So I guess you can use these for multiple thread references, which I haven't got to in Haskell before, but eventually we're going to do that. Along with creating one, we have the usual operations for reading, writing, and modifying. So read stref. Okay, so this takes the st reference and then returns a. Do you call this just like a pure version? So this is like your mutable version, and this is your immutable version, I guess, is probably the way to think about that. We have write stref, which is going to take the stref and a new a and produce. This is interesting. So this must modify the stref behind the scenes, right? Like there's more going on here. This is not a pure computation. It would be my guess. Well, okay. Got to be clear about how we say that. This is a pure function but at runtime it performs an effect that is update the value of this, right? That's the whole point of wrapping these things up, right? All right, and then modify stref kind of does the same thing, but you know, applying a function to a instead of just replacing a, I assume. Okay, and then we can write the following thing. Weird sum. All right, so I'm guessing this is going to give me 3. Why? Oh, I probably need to import control monad st, and there's probably like a run st for weird sum. There we go. Okay, so yeah, 3. And yeah, here it is. Sorry. So basically, yeah, we're sticking 2 1s into new strefs. We modify 1 by adding 1 to it, and then we do, oh, I see, this just looks like this. Then we say +1 onto read stref x, which if I remember correctly, that returns like a pure, I don't know what the right term is. I'm going to call it a pure st, or we just say a inside of the st monad such that we can add 2 of them together. And I assume you can't add 2 refs directly. You have to add them together through, you can't add 2 st refs directly. You have to add them through these states, which is the point. Or I'm sorry, you have to add them through this st monad. A lot of words here. Okay, that's kind of cool. So okay, so it says run st delimits a piece of code in which mutability is allowed. However, it never allows this mutability to be apparent from the outside. Nevertheless, purity and mutable variables seems at odds with each other. We describe how we can reconcile these worlds in the next section. Okay. Yeah, you're not allowed to dereference directly, so it's still safe. Yep. Yep. I assume we're going to get into more of that here in a little bit as well. So it says vectors. In most imperative programming languages, you not only declare one variable at a time, but also sequences of them. We say that such a variable refers to an array or vector. In Haskell, the same interface is provided for the type mvector from the vector package. To create a new mvector, you choose whether or not to initialize it with a common value. So there's apparently, let me just open up, I guess, vector Haskell. That's good water. So we're gonna go look for mvector in here, I guess. Probably don't need that. Where's new? There's only 5. And none of those are clickable. Where does this come from? Oh, this new must come from... Wait, no, that doesn't make any sense. Where does this come from? Control monad st and data stref. Oh, I can't do that in one line. Okay. Where's this new coming from? Do I need to import mvector? I have no idea where this is coming from. Super confused. Sorry. Which new is this? It's this new. Well, it's similar to this new anyway. It's not quite this one because that's an M array. We'll find it. Oh wait, I can probably just do this. Super confused, but okay. My guess is it's this one or this one, but I don't know what this prim state M thing is, so it's kind of hard for me to fully understand which one of these is the right one. Like, it seems to me like data vector mutable is probably a good place to be if we're talking about mutable vectors. Yeah, so it's got to be this one. It just looks different in the book because there's no concept of prim state, whatever that is. Primitive monad. I've never heard this before, so this is new to me. State type token, so it's probably some trick to play so that the state operates correctly on the correct thread, maybe? Not 100% sure. But okay, we're spending too much time on this, but I guess it's kind of important. So there's also a replicate, which takes an A and fills an M vector full of A of size whatever the integer is. I guess, where's the A come from here? I'm not 100% sure. So we can go look at this. Maybe it'll make sense. Yeah, this doesn't really make a ton of sense to me right now, unfortunately. I think I'm just going to keep going and hope that it starts to make more sense. But my feeling is that this prim state thing has to do with like keeping control of which thread you're operating under, similar to what this is saying about the S. The point is that all of these operations exist, so you have new, replicate, read, write, and modify, similar to the ST interface. And it says all the operations perform bounds checks and will raise an exception for any index out of bounds. For maximum efficiency, you can disable those checks by using the unsafe family of operations: unsafe new, unsafe read, and so on. So the next section is just called keeping references pure, which I think will go on to what Jappy is talking about there. But I need to use the bathroom and get more water. So you're going to have to hang on for just a second while I do that. Maybe we'll write something here. So it says keeping references pure. Most people think that there's something suspicious about ST the first time they encounter it. After all, we are injecting an imperative block into our functional code, the biggest sin, quote unquote, and getting away with it by calling run ST at the end. Why does this ability not compromise the guarantees of pure functional code? The answer is that variables inside of an ST block, a single piece of code delimited by a call to run ST, have a limited scope, At the end of the computation, all mutable variables are destroyed, and even more importantly, we cannot share variables between different ST blocks, which would amount to keeping a mutable reference laying around for an indefinite period of time. This check is not performed at runtime, but statically guaranteed at compile time, considering the following code. So is it done? So I guess it's because S is essentially a phantom that this happens, yes? So this should fail. Let var run st new st ref 0. Okay. Oh, well. So import data st ref, import control monad st. Is this the error we expect? Yeah, could it match type? Yeah, you can't see the whole thing, but if we stack build it real quick, we'll see this. The magic is in the very special type of run st. In this type, we have two variable date control monad st type run st. Okay, there we go. So we have two variables, a and s. The variable a, which represents the output type of the computation, acts like another any other type variable in Haskell. That is, it indicates that runst can produce any output type we want. We are free to choose with which type we want to instantiate a. The case of s is different. Since there is a for all quantifier in front of it, the compiler requires that the computation we provide work for any value of s that runst wants. Right, that's the for all says we choose, the caller of the function chooses what s is. This is what we refer to as a rigid or scolum variable. I'm not sure how to pronounce that exactly. I'm not sure if it's scolum or scolum. I've heard both. The reference is annotated. Sorry, I'm skipping spots. The right way to look at S is to regard it as a token that represents a specific ST computation. It's a phantom. Because of the way type checking works, well, it's a scolum. It's not exactly a phantom. I guess that's the point. The reference is annotated, so when we run this code, which doesn't work, so I'm just going to comment it. GC new stref basically produces an st of s of stref sa. When we want to use read stref from a different block, we can't do this, since the token from the second block will not match the token of the reference saved by the types. Right, so this new stref has an s that does not match with this read stref, so they do not work because of run st, by the way. That's what makes this work. Okay, so next section 8.2 interfacing with the real. By the way, the real world isn't in quotes. I'm just giving it a very Neo-esque thing. I don't know. Is the world really real? I don't know. Okay. The IO monad is as powerful as a spaceship, but also as powerful as Pandora's box. It's a weird sentence, but okay. In Haskell, the IO monad grants access to external libraries, to the file system, to the network, and to imperative model of execution. We need it, but we want to stay far away from it. We want to stay far away from it as much as possible. Okay. It is impossible to describe all the possibilities inherent in Haskell's IO monad. For the sake of simplicity, we are going to restrict ourselves to simple actions. Why are we doing this? I guess it's just okay. So this section is just pointing out that like put stirlen, get char, get line, and you can write like a greet function, you know, something like the following. I think that we understand this, so I'm not terribly concerned about it. Right, so we could do something like this, for example. It's just that these things exist, and there's also randomness that you can get from here. So there's random IO and random RIO. So the one is just restricted to a certain inbounds. So purity. Hasklers often emphasize that their language is purely functional. A pure language is one that embodies the idea that equals can be substituted for equals. The idea is also important in mathematics. Haskell's solution. Okay, so it's just saying like if you generate random numbers with IO, you know, there's no way to run the same thing twice essentially, because there's no way to substitute the answer in the same place. If I had like, you know, a random number or a random string generator here and I ran this function twice, I would not get the same result. Haskell's solution is to mark those values for which purity does not hold with IO. Since random RIO generates two values of type IOA, we cannot directly apply the equality operator to them, as no instance for IOA exists. Right, okay, so if you had like IOA, two IOAs, let's just do that. So like A is IO int or something, A equals pure 1, and then we had B pure 1, you'd have to do something like C is equal to do, you know, A prime from A, B prime from, well, actually, let's do it with applicative, right? Nope. Right, we could do something like this. So, and the reason you can do this is because, you know, you can compare the things inside of the IO, but you cannot compare the IO directly. So you can compare these ones, but you cannot compare them from outside of IO. So you have to compare them inside, I guess, is probably the way to say that correctly. Maybe. Okay, so that was just one point on purity. There's another point about description versus execution. So I think we talked about this before, but I'll talk about it now. IO values are treated like any other value in Haskell. They can be used as arguments to functions, put in a list, and so on. This raises the question of when the results of such actions are visible to the outside world. Take, for example, the following. Map put stir len right, if we had something like this generates a list of IO string, but if you execute it, nothing will be printed to the screen. What we have created is a description of a list of actions that write to the screen. You can see this in the type assigned is, yeah, we can just say, oh, it's not IO string, I'm sorry. This is actually a D IO list, nope, list IO unit. Right, because the type of put sterlin is IO unit. Yeah, but this doesn't actually print anything. It just tells you it's a list of things, of descriptions of to print things. The fact that IO actions are not executed on the spot goes very well with the lazy nature of Haskell and allows us to write our own imperative control structures. Okay. So to flip this, essentially you need either sequence or mapm. So you can do a few things to just have this execute. You can say E is sequence D or you can write something like this. So there's your two options. Says this distinction between description and execution is at the core of the techniques explained in chapter 13 for creating your own fine-grained monads. But even for a monad with so many possible side effects like IO, it is useful for keeping the pure and impure parts of your code separated. It says, for that reason, people use IO in languages in which side effects are available everywhere, such as Scala. I don't want to talk about Scala. There's some unsafe perform IO written in the Scala code, and it basically just says you should know that this function exists only so you never use it. So never use it, apparently. Now we're going to talk about exceptions. I feel like this is kind of a pretty a building chapter. 8.2.1. Oops. So hopefully I want to do some exercises. This is the part that I don't like about this book, because there's not a lot of exercises. And I don't want to sit here and just talk to you for, like, it's boring. I'm not having very much fun doing this particular stream. And I would argue that the viewers are feeling the same way, because there's only 2 of you left. I think we had 6 or 7 at one point. Then I started talking. All right. There are two sides to working with exceptions. First is raising or throwing the exception. In that moment, the flow of the program is cut off and control is given to the nearest exception handler. Declaring which part of the code is linked to each handler is the second part of dealing with exceptions. In Haskell, the functions used to throw and handle exceptions are centralized in a single module, control.exception. And they give you basically two functions, so let's look at them. I know you can't see everything to like the complete right, but it'll come up as we move along. So import control exception type throw. So this takes some exception and returns an A. And then there's also throw IO, which takes an exception and returns IOA. Exceptions can be, so one thing to point out is that exceptions can be thrown from pure code. So that's what this is doing. And then this is being thrown from IO or code in IO. The second, not every type can be used as an exception. It must be an instance of the exception type class. For every domain in which a new kind of exception makes sense, you have to declare the corresponding data type and then make it an instance of exception. So as an example, we could say database exception equals, connection error. And then you can write instance exception database exception, but we need to import control exception. I'm guessing this is going to complain that we need to show driving show. And I think there's typable as well. Typable? Let's get rid of this and see what happens. Seems fine. I'm not sure what the typable part is for. Oh, there's something in here about deriving show and typable. I'm not sure why. Anyway. Haskell's base library comes with a wide range of built-in exceptions, such as IO exception and arith exception. The most common way to handle an exception is to use catch. The first argument is the operation you wish to perform. Yeah, it looks like the catch error function from before. So we could try and, for example, divide by 0 and catch an arithmetic exception like so. We're on G, I guess. Print amount divided by number of people. Sorry, you can't see this. Hang on. Put Sterling. I'm not sure that that's a great error, but okay. No, this should go here. That should go there. Oh, and then we need to take amount and number of people. And that should work. Alright, you can't actually read that exactly, but it's pretty close. It's close to fitting on the screen. We'll just leave it like this. I don't want to make it any smaller in case you can't read it. Okay. So that's an example. It says if you really want to handle any exception, you can use some exception as the type. Okay. The library defines handle as catch with the order of arguments swapped. In some cases, it might be more understandable to declare the handlers before the main computation. So we could write like, I'm gonna write an equals handle just to show some exception. Broke. And then I guess you nope. Something like this. Wait, why does this work up there? But it doesn't work here. Oh, I probably need a print or something. That's kind of weird that that works, but it probably has to do with the way yeah, it keeps formatting things in a weird way that make the lines too long. So maybe what I can do is just that. Oh, we don't even need that, so I'll do this. This is probably better. Also, hey, Vic, how's it going? Okay. Ow. So it says if you want to handle not one single type of exception, but several of them, it is advisable to use catches instead of a sequence of catch calls. The reason is that by sequencing catch actions, you create several enclosing regions of handling. It becomes difficult to guess what happens if one handler raises yet another exception. In contrast, catches creates one single region in which each handler is tried in succession. Okay. So basically, instead of having catch here, you would have catches and then a list of handlers. So this is one handler. So you wrap this in a handler and then just stick it in a list. So we could basically copy and paste this. I figured by putting pure there, it would realize I meant, although maybe it just needs to be a $sign here. So we could catch like an arith exception and then do something like the following. If we wanted to say like like what happened? I don't know, something like that. I think, yeah, so something like this you can do. So basically just trying to point out, I mean, there's a lot of this book is just like pointing out what exists. So one unfortunate consequence of the introduction of exceptions is that error handling in pure code becomes rather different from that in I/O computations. The first approach to reconcile them comes from the try function. Okay, so the try function turns, let's see here, the exception. Okay, so it says any exception during the execution of the given computation is turned into the left branch of an either. A more powerful solution is embodied by the exceptions package, which defines a couple of type classes for these monads that may handle pure or impure exceptions. So we get monad throw and monad catch, which I think look very similar to the well, I mean, they're called throw and catch, so they must be very similar to the things we just encountered in the last chapter, which were, what were they called? I already forgot their names. Throw error and catch error. So there's a monad error, and then there's a monad throw and a monad catch. And the only difference between them is that monad throw and monad catch can handle exceptions, and the throw error, catch errors do not handle exceptions, I guess. You need to use the other monad for that. In addition to I/O, the type either some exception is also a member of that class. In most cases, defining your functions in terms of these classes is a net gain, as it allows you to use I/O in production code while using either, which is easier to inspect during testing. Okay. Because there's another problem with exceptions in Haskell. This one due to the laziness of the language. Okay, so let me write this code and we can see if it behaves the way they say, because I'm kind of curious. So AE, rational, rational, rational. So it's numerator, denominator. Sorry, I just realized like it's got to be in IO, and shouldn't there be a do? I guess there doesn't have to be because there's just one return statement. Can't divide. with show D. And then something like this, I guess. And then apparently if I run this code with 0 as a divisor, you will not see the expected error message. Okay, let's find out. Interesting. So it says briefly, the problem is that the moment in which catch does its job, the result of n over d is not evaluated yet. As a consequence, there is no exception being raised at that point. Only when we try to print the result does the evaluation take place, but then it is too late. The safeguard of catch is already gone. To fix this problem, we need to force the evaluation of n over d. We do so by replacing return with evaluate. Apparently there's two exceptions, or I'm sorry, there's two packages for exceptions. One called safed exceptions and the other one called unlift.io, which makes this a lot easier. So we might have to look at those at some point. So we can fix this apparently by changing this return to evaluate, which is a strict version of, I guess it's a strict version of just return. It's coming from control exception. So if we do reload, there we go. Can't divide 1 with 1 is 0 with 1. Okay. Well, as rational numbers, that is. Okay, the next section we're just like rapid firing through these sections, but there literally has not been a exercise yet, so I apologize for that because it's mostly just me reading and I really don't like these nights, but they happen from time to time. I feel like because there's really not a ton to experiment with, I feel like it's a little, there's not much to do. I don't know. Okay. So it says we introduced ST as a way to have mutable references in a block of code while maintaining our purity guarantees. But when we work in I/O, we might need to put those guarantees aside. For example, if we are building a web server, some state might be shared between all clients, like the database connection pool. The solution is simple: use an I/O ref, the unsafe version of stref. Okay. So it says, in contrast with strefs, IO refs are not tagged with the specific region they belong to. They don't have that the for all s that we had with the strefs, and therefore you can just freely share them around your code. So it says, when you are writing a web server, things are not that easy though. Each client is usually assigned a different thread of execution, and all of the active clients execute concurrently. Creating a new thread in Haskell is simple, as you just need to call the fork.io primitive, which returns an identifier that can be used for canceling or otherwise manipulating execution of the thread. IORef doesn't offer any guarantees about a concurrent environment. There is some level of atomicity available through atomic write IORef and atomic modify IORef, but the right solution is to move to mvars, variables that could be either empty or full, and whose semantics are safe for multi-threaded programs. They don't go into it in this book, but we have the book that explains how mvars work, and we will do that at some point. So, okay, so mvars are kind of like IO refs, but have better semantics for multi-threading and asynchronous programming. Okay, so I don't really have anything to say about this. What I'd really like to be able to do is stop having that happen, but I don't know how. I suppose I could make like a macro for it, but it seems like a weird thing to do. Okay, very tired. I apologize for yawning. If your goal, kind of have a headache too, so I'm doing my best here. How much longer is this chapter actually? Ooh, nice. There's an exercise on the next page. That's exciting, and it's going to be about transactional variables. Here we go. You getting excited? I'm excited. Okay. If your goal is to communicate information between threads of a single application, mvars are not your best option either. The best guarantee are offered by software transactional memory, STM for short, which brings the idea of atomicity from databases into regular code. In the Haskell implementation, each transaction is represented as a computation in the STM monad. Continuing with the theme of variables, transactional variables are called tvars. They provide the same set of operations as IORefs and STRefs. Their difference from normal variables is that in a certain block of code, you may access and modify several transactional variables. In the following piece of code, we use two of them, a counteracting... Sorry, in the following piece of code, a counteracting as a source of identifiers... Whatever. I get it. A counter. My cadence is wrong, and therefore I'm being confusing myself. A counter acting as a source of identifiers, and a list of names paired with those identifiers. That's kind of funny, actually. So let's put this up top. So we got add name, tvar, integer, tvar integer, tvar integer string, wrong arrow, string, STM unit, add name, counter, names, name. All right, so we read some integer from a tvar. We modify tvar. I'm guessing names. Yep, counter. Name. Right, so essentially we're just prepending counter and name to whatever is in there. Okay, and then we need to go get these things. How is there no action available? Oh, it's probably because I'm using the scope type variables thing. Do I actually need that? Yes. Apparently I do. But it seems to be breaking my ability to go figure out where tvar comes from. But I can probably make a guess that it comes from here. Tvar, maybe? I don't know where it comes from. Tvar. Control concurrent STM. So that's an option. There's also GHC concurrent. I don't know which one's the right one. Yeah, it's got to be this one. It says it's in base as well. Or wait, I think that's what this means. Yeah, it's got to be this one, right? Okay, let's look at this as well. Yeah, it looks like the same thing. So I think it's just GHC conc. Modify tvar. So it doesn't appear that we have modify though. Interesting. So what do we have to work with? My nose is really bothering me right now. So I guess we just read and write it because there's no modify. So we have like I guess it's supposed to be like read tvar names and then write tvar names ns. Like so. Okay, so the tvar stuff in GHC conc is in IO, not in STM. I think you need STM package. The STM library stuff just imports from GHC conc. Oh. Okay, so Lumi says we should use, well, I guess Ann Simon just via a different route is to use this. Okay. I mean, we can still write it like this, right? I mean, this is the same thing. It's just that we don't have as much functionality. Let me put this up here. Although I suppose it doesn't really matter. Right? Because we're just getting both the transactional things and then writing names back and incrementing the counter. I think it's right, but I mean, I'm not super familiar with TVARs, so like I can't really, I can't be 100% sure. I'm only whatever percent sure I am, which is less than 100. Estimating is hard. I also just realized I didn't update my stream title again. Oh well. Okay, so it says modify the code above to guarantee that no duplicates exist in the list of names. In other words, the code should only insert a name if there's no pair in names that already has it as its second component. All right, so I feel like we want to reach for a guard where oh, I suppose if we just import this as well, our code doesn't change at all. So like, I think if we just do this, that should have worked. I just did. So maybe it's not obvious, but yeah. So that thing is supposed to add it for me, but it seems to still be complaining. Whoops. So yeah, usually that works, but who knows? No, it did not mean STM. So I probably also need to import STM. Oops, my bad. Control monad. That's where guard comes from, right? Okay, now we're in the errors that actually matter. Oh, I guess I need to... I'm not filtering. This isn't right. Oh, I could do that as well, but... yeah, I guess that would work. That would be fine too. I was thinking, oh, I could just map this this over NS and then check if any is bool, but I guess I'm doing more work. Good call. Right, so, okay, what is this doing? So if I write this, it's basically checking that. So if it can't find name in here, then this will be null. We want this to return true if that exists. So that's what the not is for. So if this thing is true, with an F map in there, right? Do I need an F map or no? I gotta look at the type of any. Oh, right. Okay. NS is just a list. Yeah. So any takes an A to bool, which is exactly what we want. So I think I just forgot what the type of any was. That's all. Yeah. I was thinking that for whatever reason, any took a list of bool and returned a bool. That's what I was thinking. Like this function, whatever this is. That's what I was thinking. So it would be or, I guess. Okay, anyway. So yeah, I think this works. I don't really know how to test this super easy, so I mean, we can try. Let's see if we can do this. So if we had like, what was the last character I used? I. So if we had like a J, which is a tvar integer, J equals pure 1, pure 0, I guess. Okay. Let's go in back here and look for tvar and figure out how we construct one. Oh, wait, I know how to construct one. Just new. New tvar. It looks like STM is actually implemented in GHC RTS in C. Interesting. So deep down, this is like just C code. I don't know what runtime system is that. RTS. Okay, I guess I don't need this, right? I just need the second thing. So this is like, so this is just like a map, I guess. So we can just write, 0 Sperry and I don't know, 1 can be Lumi since you talk last. What's wrong with this? Okay. So is this supposed to be... Is this supposed to be STM of unit and then I return this thing. Or is it STM of this whole thing? Okay. So this STM behaves like the IO, right? That's the point. So this is returning. This doesn't do anything. I don't understand. Well, let's see if we can figure this out. Let me put this down here though. All right, so if we were down here, we wanted to write a function that was called, actually add name. Let's call it add Simon, I guess. Since you were the second to last person to talk in chat. So add Simon is going to be an STM unit. Actually, no, we want this so that we can basically run all this stuff. So we're gonna have to run STM run tvar, I guess, or something like that, to try and get this thing back out. So this is gonna be essentially, I assume that it has a do interface or a monad interface, so I can write do here. And then we need to go get the tvar inside of n. So names equals, I wrote, is n. And then we want to how does this work though? Is it because I'm using tvars that this will work? Does names contain the thing I think it does? I guess we're gonna find out. Add name. Counter. Yeah, but the counter just kind of goes. Yeah, the counter is sort of separate, I think. I'm not too concerned about the counter, but I think we just write new tvar 0 or something here, which would be fine. Because I'm not concerned about, although do I need to make the counter outside of this is the question. Maybe I need to do, wait, no, I don't, because it's got to be a, okay, okay. So new tvar 0 or something, and then C, right? Because this will be a tvar anyway, right? Because it's inside the STM monad, and then names is just this tvar, and we need to add a string, right? So we're gonna add Simon. And then we're just going to put names here. Like this. Oh, this needs to be completely outside. That's probably the old names. That's probably the old names. This... Yeah, that's what I was thinking as well. Because we're writing the tvar names and counter. Okay. Okay, I see what you mean. I see what you mean now. Sorry, this is a little different than what I'm used to. I can't use C, so we'll use M. STM tvar. Right, because I'm integer equals new tvar 0. All right, so wait, wouldn't that instantiate a new one every time? A new what every time? I have no idea, actually. Let's see what happens. I truthfully have no idea. So let's see what happens. So add Simon. And we need to save this in some sort of variable. And we might as well say like this, right? Oh, I guess I can't. So we gotta write run t bar dot run stm synchronized. What's synchronized? So we need, oh yes, there's some, okay, yeah, you're right. It says in the book, actually, on the next thing, it says you need automatically to make this happen. So automatically, it's supposed to be atomically. Okay. I'm tired. I see. I still want to call it automatically, which is kind of funny. I probably want to get it from here though, right? Yeah, we've talked about including LambdaBot and also including like other bots as well. There's just so many bots. So many bots. So control mode at STM. So atomically add Simon. Oh gosh. Where'd HTOP go? Okay, so yeah, this doesn't work. I guess technically this counter should be 2. Yeah, no worries, Simon. I'll catch you later. Thanks for hanging out. The one thing that's really weird is that he's got down here that you write atomically add name and then some name. So I don't understand what that means. Like, how does that work? So if it's this, okay. Like, this doesn't take a string, so how could this possibly work? I really don't understand. Okay, let's try this, and let's see if we can do add name n m. It's the counter, so m n berry or something. The new examples I see perform new tvar outside of STM. Outside of STM. Yeah, but this doesn't type check if I do that. Okay. Like, if you write this, it seems to think that this should happen in the... Do I need to run STM? I thought the point of the run... Well, let's try it. I mean, I don't know. I don't know what I'm doing. What? New tvar in IO. Is that what I want, though? Yeah, I'm not sure either. I don't know how to use this function even. I'm having a hard time understanding how I use this function. Because it doesn't seem to me like it... Like, how do I... Okay, so if I create this, let's say, and get rid of this. I think it's what you'd want if you split the transactions. Split the transactions. I'm not sure what you mean by that necessarily. This doesn't work, so let's get rid of this. So what happens if we like just atomically do this thing and then grab it? Do we really get empty list? So we're gonna write like, yeah, I don't know why that's stuck in my head. I can't get automatically out of my head. Yeah, that's fine though. I just want to make sure that it does something before we move forward. So n. Run t. So this gives me a t-var of this thing. How do I get the value of a t-var? Do I have to run it again? No, because that's an STM. I don't. This doesn't really make a ton of sense to me right now. I also have no way to know if this is correct because I don't know how to figure that out. Like, I don't know how to make these things happen. Like, how do I create this counter? Where do I create this counter? Because it's not an STM. If I wrap them in STM, can I just do new, do you think? Oh, do you know the answer? If you know the answer, you can just tell me. Read. So I do have to do it twice? What's read tvar again? I see. Okay, it's similar to the other one, the stref stuff. Um, so atomically, Do I need to write? Sorry. So I need to write like atomically n read tvar atomically? Gosh, this is weird. Weird. Yeah, so this is actually what you said before. I misunderstood you the second time I rolled in here. What jobs do I have in here now? Okay, so oh, right. Good call. Good call. So I don't think so. I mean, maybe I didn't read it carefully enough. Like, all operations in the block are treated as an atomic block that executes over a consistent view of the data. But, like, it's only maybe 4 paragraphs long. Maybe that's just not long enough to understand STM fully. And I shouldn't think about this that carefully until I get to Simon's book. I'm not really sure. I certainly don't feel very confident about this. It also doesn't explain how to run this. On literally 2 lines after the exercise, it says atomically add name and then someone's name. It's like, well, that will never work, because add name takes, these counters and names. So like you can't call add name with only a string. So I that part I got really confused about. But what I would like to do is use add name to just add a name. Like, I want to do that before I leave. I feel like I should be able to do something like that, yeah? So I want to create IO whatever. The names N and M prime are not helping me out here very much, but so read, sorry, I forget what read tvar is doing again. That gives me an STM. Oh, right. So print dot atomically I need to see the errors. I'm having a really hard time here. Having only the partial errors is not very helpful. I mean, so if it creates that, then shouldn't I be able to just... Oh, okay. So what I was doing wrong the last time was I needed to do like this, then res, well, just print. It needed parentheses, right? Oops. Oh, okay. What did I do wrong? I don't remember what I had. But okay. And then it also says apparently we can use read tvar io. Do we think this is gonna work? Why do I want to put that there? Okay. Do we think this is gonna work? I think that yup is from something else, so. I don't think it's gonna work. It just doesn't mean anything to me. I just wish that they showed how to use this function. It's a little frustrating when, there's code in the book that in theory you should be able to use, but it doesn't make any sense. Like, we modified the code. That was actually not that hard. It's just kind of following the types, but the fact that it doesn't show how to use this code is a little annoying to me. I find this kind of stuff in the book really frustrating. It's not just this book, it's any. You think so? I mean, I'll take that as an example idea. Oh man, very unfortunate. So if we add you, is there? Yeah, see, it will replace it every time, but that's fine. I mean, I wasn't that concerned about that. Like, I just wanted to see it work. So essentially, this doesn't work. Okay, so let's fix this and then, well, I'll try to fix this. So what if we use... I was thinking that we would be using guard here because we want to basically say, like, guard against this case, but we're apparently stuck with using guard. Okay, so maybe there's like something useful in here. Check. I don't think it's this. Although maybe it is. Maybe you just do... Or maybe I need to... Can we sequence the writes? That's a question. So if I just put a... Can I do this? All right, so then I could just do check. I don't think it's check. If not, retry. That's kind of the weird thing. That's what you're saying. We want to avoid this retry. So actually, we definitely don't want check, right? Like, well, fair enough. I don't understand them. Okay, let's do it the dumb way. Ready for the dumb way? Oh, wait, hang on. I need this. I can do it the dumb way. I'm totally fine with that. Fine, I'll use if. I don't care. The wrong thing. Now, the question is, how do we get rid of this piece? We don't need to write them. Oh, or else. Did I miss that? Oh, I guess I did. The first action completes without retrying. Then it forms a result of the or else. Okay, can we try my dumb version first, just to see if it actually does what we want it to do? The key is I just need to put something in here like this. Well, that doesn't work. I probably have this wrong. Second equals name. If it's null, then add it. Yeah, so. Yeah, and this is just any. Oh, well, okay, now I have these backwards. Yeah, it's bad. The problem is that I get frustrated and then I fall back to old habits, right? Like that's the problem. Like I know that actually is more convenient for this, especially when I'm doing stuff like this, but then my muscle memory kicks in and I stop doing it. So I'll try. Thank you for reminding me, though. Okay. I mean, good enough. The behavior is not correct because except I did it again, right? Because I had that in the foreground. It's good enough. I'm not that concerned about it. It seems to me like this really needs to be I+1 because although I don't know what this structure is supposed to be, so it could just be 0. The next counter would be 1 or something. I don't know. Like this 0 doesn't really mean anything, so it's probably fine. Ideally, you would want to add a bunch of names, but I don't know how to do that because I don't understand this STM stuff. So let's not worry too much about that. Okay, so let's do this, and we'll try and write Lumi's solution real quick. So we want to use or else guard essentially not null filter pure wait, does it need to be pure? Don't these return? Oh, okay. So it does, yeah, it doesn't need to change. Actually, it's probably a lot cleaner to write it the other way. I assumed you only wanted to do writes in one case. Yeah, I that's correct. Oh, I see what you're saying. This isn't an STM. This needs to be an STM, so I need to put a pure around this? I don't understand. I guess I don't know what to do with this. Maybe I misunderstood what you meant. Right, because this is an STM. Maybe I need to put this in parentheses just to make sure it's not that. It's apparently that. So basically, the or else is just preventing the retrying. Right? That's the idea. So if any of these are true, but this isn't right, it's like all. It's supposed to be, I think, all not equal name, I think is the right way. I'm gonna try it. I did it again. Yeah, the logic is right the first time. Okay, there it is. I think this is what you mean. Right? This one. Not quite. Okay. Yeah, I'll see your gist, but then I need to get off because it's super late, and I have a pretty awful headache. Would it help you if I copied and pasted any of this into chat? Because I can do that. You just tell me if you want this whole thing. Okay, sorry. I just thought about it. Thank you so much for your help again, Lumi. Like, you're insanely helpful. But again, I think that this is one of these things where I just don't fundamentally understand what's going on. So I get kind of stuck. The last bit of this while we're waiting on this gist is essentially just pointing out that I should read it carefully. It says STRefs and IORefs, it's clear that both types share the same concepts and operations. They're so close that the primitive package is able to provide a common interface by means of the prim monad and shared mute-var type. What is even more interesting, the mute-var type is not declared using any kind of type magic. It just takes an argument, the prim state of the corresponding monad. It looks here like IO is a state transformer monad that transforms the entire world. The intuition is correct. If we ask the GHC interpreter for information about IO, this is what we get. State, real world A. Okay. We'll test it. I can test it for you. You wrote it. I'll test it. That seems like a fair trade-off, yeah? I just want to put it here. Oh, right. Okay. No, this is a variable not in scope. It's... Why doesn't it know about that NS up there? Let's do it this way, I guess. And we'll try it. I'm done after this, so. Yeah, I think the logic is backwards again. So this one needs to go the other way, I think. Oh, you said that. I just noticed. Sorry. I think that's what you mean by that anyway. Perfect. I guess this is not super dumb. It's just all is not any. Really? It's kind of funny. Yeah, I think I knew what you meant. Wait, what? Well, I switched this as well. Right? You want this to be true so that the guard triggers the. You want this to end up being true. So they all need to not be equal to the name. Whereas in this case, that's okay. I'm super exhausted as well. Like the fact that the only reason I realized this was because I ran it and realized that the logic was backwards. Like it's hard for me to get this stuff. Right, in this case, we want to we want this to trigger. Yeah, it's really confusing actually. It because of where we put or else, I guess. Or the way we're using or else. Yeah, it's fine. I do this all the time. I goof that kind of stuff up, so. Why does this happen? So we want to make retries happen. Why does this work? So this triggers a retry. So when this triggers a retry, do this thing. When it doesn't, just return unit. Yeah, okay. I got it. So we're basically just writing the same function in slightly different ways. Right here, you want this to be the second situation, so you guard for the opposite thing. Otherwise, you return unit. You like this the best? Okay, well, we'll leave the simplest solution because I find these or else ones a little difficult to reason about in my head. So we'll leave this one uncommented. Similar to 2, but flipped guard. All right, so I think that's it. We're definitely done for the night, and I'm just going to read this last paragraph real quick. In the chapter, we focused on mutability, but this is only one of the features provided by I/O. Its other main use is accessing resources outside of the program itself, such as files or networks. As we'll see in the following chapter, I/O on its own does not provide enough guarantees for even the most common of such scenarios. So we need to learn next about more restricted monads. So the next one we're going to talk about is resource management and continuations, which is exciting because I feel like we didn't understand continuations the last time we used them. So I'm very hopeful that will work. To clarify, the solution I have there is wrong semantically. It should retry if write tvar fails, but it doesn't. Oh, I see. Is that true for this one as well? For number 2? No, right? 2 doesn't suffer from that deficiency? Because these still have a chance to retry? Is that right? Okay. I thought that only this part would cause, like, if these retry, although I don't know the entire behavior of or else, so maybe there's something else there. It's down here. Maybe it says something about it. Well, reading this, I guess it's not completely clear. I don't understand this or else, so I should just not worry about it too much right now. We'll come back to this when we talk about the parallel and concurrent programming book, and we should stop. I need to stop thinking about this because my head and I am also tired. So yeah, we're done for the day. Just a reminder, you can get this book because I'm supposed to tell you no one would write that code. Which code? This code? Or the code we wrote? Is what you're saying. This code no one would write. Or this or else stuff. They would just write this. Mm-hmm. Yeah. But you think people would write this as well? Even if it suffers from the same problem? And by that I mean 3. You should only write 1. Okay, I'm fine with that. If that's the case, then it's totally, all others are wrong. Maybe we should write that. So 2 and 3 suffer from a issue with retry. Only the above is truly exhibits the behavior we are looking for. Let's just say that. Why does that keep happening to me? I don't know what I'm even pressing at this point. I'm too tired. Yeah, see, thank you so much again. Also, one is much more readable. Okay, let's push this